Hi all, myself Subitha Sudheer, Assistant Professor, Department of Space Science and Technologies and Albertian College Autonomous. So today our topic is about Spearman's rank correlation coefficient. So Spearman's rank correlation coefficient is used to measure the correlation coefficient between the two variables. So there is one more tool we are using, correlation coefficient quantitative tool for finding the correlation between the two variables is actually called Pearson's correlation coefficient. But the major problem of Pearson's correlation coefficient is that which will measure the correlation between the quantitative data only. But in the case of statistics, the data can be qualitative also. So what will happen when the qualitative data will come, or we have to find out the correlation coefficient between the qualitative data. So there we are using the Spearman's rank correlation coefficient for finding the correlation between the qualitative data. So like the name indicating, Spearman derived a particular method for finding correlation coefficient of qualitative data by using the ranks. So if you can find out, or if you can rank a particular data based on some criteria, the qualitative data based on some criteria, then you can find out the rank correlation coefficient. That is actually the essence of the Spearman's rank correlation coefficient. So the rank correlation coefficient is actually obtained from the ranks of the qualitative data, not from the quantitative measurements. So this is the formula for finding Spearman's rank correlation coefficient. That is actually 1 minus 6 into sigma d square by n into n square minus 1. So when compared to the Pearson correlation coefficient, it is very easy to find out such a Spearman's correlation coefficient because the formula is very small and it is very easy to find out the Spearman's rank correlation coefficient. But the thing is that it is used for the qualitative data. So this is an example that is given to you. So here you can see that there are 10 individuals and the rank before and rank after data. So the data or the question is with the ranks of the individuals. So here you can see that the individual A have the rank 1 and A have the rank 6. So this is the before rank and this is the after rank. So which indicating the position or the rank of a particular individual. It does not showing the actual mark that he got. So this particular data is not indicating A get 1 mark before and A gets 6 mark after. It does not indicating that whatever scores that is gained by A, that is not given as the problem. So that data is not the mark is not explicitly given. So it's just given the rank, that is how we rank the 10 individuals. That is A got the first rank in before, then 6th rank for B in before, and 3rd rank for C. Should be like this. So these numbers are not the exact mark gained by the individuals. It is actually the rank. Some way we are actually ranking the 10 individuals. So the ranks are given to you and the question is also a direct question, calculate Spearman's rank correlation coefficient. So the next thing is the calculation procedure. So this is the formula that we have 1 minus 6 into sigma d square by n into n square minus 1. From the particular formula, it is obvious that n is the number of observations, that is number of pairs of observation that is given to us. So the next thing is we have to find out sigma d square. So let us think about what we mean by d. So d is actually the difference between the ranks. So here you have the two set of ranks. Find the difference between the two set 1 and 6. The difference is actually 5. So you can take the difference either from 6 or either from 1. It's not a problem because here we are calculating d squares. So if we get a negative difference, when we go to the square, it will be positive. So it's not a problem whether we have to take the difference from 1 from 6 or 6 from 1. So after finding all the difference and squares, find the sum of the squares. So here we got the sum as 176. So substitute the values here, substitute the formula. So the value of the correlation coefficient as minus 0.07. So the next thing is how we can interpret such a particular answer. So here we get a negative value. So we can say that negative correlation. And look at the quantity 0.07. So it is approximate to be 0 but not 0. So we have to say the conclusion as there is a negative, very low correlation between the two variables, that is the two set, that is rank before and the rank after. This is how we are interpreting a particular answer. how we get a particular interpretation from a particular answer for a particular question. This is another type question. Here we can see that there should be a two set of data, but when you look this particular data, it is clear that it is not a rank because the exact data is given to you. So, but the question is find the rank correlation coefficient. So, for finding the rank correlation coefficient, we need the rank, but here we are given with the exact quantity of data. So the first thing is we have to make the rank of this particular data. Then after that we have to find out the rank correlation coefficient. So this is what we did as the calculation table. So the poverty, the values, values highlighted in yellow, that is whatever given in our question, that is actually the quantitative data. Then in the red color I am highlighted that the rank of the particular data. So I gave a rank such a pattern that for the highest value I give first rank, the second highest value give the second rank, for the third highest value get the third rank. So it will be going like this. We have the 10 marks or 10 values are given to us. So the range of rank will be range from 1 to 10. So likewise, we make the rank of the values of overcrowding also. So we get the two ranks, that is colored in to red. Then find out t square values. That is whatever we did in the previous question. Find out the difference of the squares between the two values. Then find out the sum. The sum should be 44. Then apply the formula 1 minus 6 into sigma d square by n into n square minus 1. So we will get the value as 0.733. So this is another type of question. Here the question is same, find the rank correlation coefficient. But the thing is that you are given with the exact data, not the rank. So if you are given with the exact data, first you have to find out the rank of the data, then find the rank correlation coefficient. Then there is one more variety problem. So what will happen if you are trying to assign the ranks for the data? If the data is a repeating one, okay. So if there is a repetition in data, so what will happen? How we can assign the ranks for a particular data? So that is what we are discussing. A repeated data or tie in rank. So if there is a tie in rank, while we are given rank to the particular data, so there is a small change in the formula also. We add a particular quantity in the rank, Spearman's rank correlation coefficient as sigma mq minus m by 12. So there is a small change in the formula also. So this is a problem regarding such a classification. So here you are given with the two set of data x and y. But when we come to this particular data set x, we can say that there is a two repetition. 75 is repeating two times. 75 and here is also 75. So how we can assign the rank when there is a repetition of data? So it is not possible to give for the first 75 as the first rank or the second 75 as the second rank. So what we are actually going to do that. So here look at the data. Here the highest value is 80. So that is I go the rank as 1. Then so the next highest 75. So 75. So here we have 275. So we have to take the average of the ranks. So the next rank will be 2. The other next rank will be 3. So take the average. So 2 plus 3 by 2. So the average will be 2.5. So we have to assign the average of the ranks if there is a tie or the repetition in data. Then we assign the rank 2.5. So the next highest value as 68. So but the second rank and third rank took part in assigning the rank for the 75. So we have to start with the next rank, that is 4. So have to give the fourth rank for the value 68. So this is how we are giving or assigning the ranks if there is a repetition in data. Then so this is the rank of x. The same procedure is given happened in the case of rank of y also. So we get d square. Then when we come to the formula, we have a quantity sigma mq minus m. So m is representing the number of repetition of values. For this particular entire data, we have to take all the values which have the repetition. So that is what I am mentioned here. Here we have 75 occurs 2 times. So m is equal to 2. mq minus m is equal to 2q minus 2, that is equal to 6. Then we have to count all the repeating values, and the number of repetition will be m. So we have to find out all the mq minus m. Finally find out the total of mq minus m, that is actually 36. Substitute here, we will be get the value of the rank correlation coefficient as 0.545. This is the how we are calculating if there is a repetition in data. Spearman's rank correlation coefficient. So the next thing is merits of Spearman's rank correlation coefficient. So it is very easy and simple to understand. So if the data is in a qualitative form, it is very useful to find out the correlation coefficient. Then the limitation of Spearman's rank correlation coefficient. So it is not possible to use for a grouped data, otherwise the frequency distribution. And if the n exceeds the 30, it is also very difficult to find out the Spearman's rank correlation coefficient. Then advantages of correlation studies. It is one of the major thing is that correlation studies enables the comparison of data, or it is finding the relation between the two variables. So correlation, the next thing is uses of correlation. So it establishes a relation between the two variables, which check whether there is a relation between the two variables. It's also helping because the correlation and the regression tools are highly related. So the regression is doing the prediction part, but we have to we can enter to the regression through the correlation. So the correlation is helping the prediction, helping for the prediction purpose also. Okay, thank you.